Write down next chapter, gravitation. The first one is gravitational force. So the formula is G m1 m2 by r square. G m1 m2 by r square. Write down. G is equals to gravitational constant, and the value of G is 6.67 into 10 power minus 11. 6.67 into 10 power minus 11. G is equals to 6.67 into 10 power minus 11. So what is the unit of the G now? Newton meter square per kg square per second. This is Newton, no? This is meter square. This is kg square. If I take everything to one side, it will become Newton meter square per kg square. Write down. So whenever they are asking any one unit, keep that one unit either left hand side or right hand side, take remaining to the other side. Okay. What happened? You didn't get it. Fr square by m1 m2 is equals to G. Can I write like this? So this is Newton and this is meter square and this to kg square. So it is nothing but Newton meter square per kg square. Okay. Write down the first point. If mass increases, the force increases. If the mass increases, the force increases. Next point, if the distance between the mass increases or if the distance between the object increases, the force decreases. The force decreases. Third point is, see, listen, whenever we are talking about a gravitational force, no, it's always attractive force. It's always attractive force, there is no repulsive force for this, there is always attractive force. Okay. And similarly whatever we are talking here no will be discussed in class 12, that is electrostatic part. Okay. F is equals to k q1 q2 by r square, remember the formula. So there we are talking about two charges, one is positive charge, one is negative charge. So there we talk about two forces, one is attractive force and one is repulsive force. So in electrostatic two forces are there, but in gravitational only one force, that is attractive force. Okay, it's always towards the earth, we'll say no. So only attractive will be there, that's the third point. So from this equation no, I can write F is equals to m into g also no, yes or no, and I rewrite this as F is equals to g capital M small m by r square. So can I equate this equation now? I have taken this in terms of m1 m2 no, previously I have taken capital M and small m. So capital M is the mass of the earth and r is the radius of the earth, and small m is the object which is present in the earth. Okay. Now if I equate this, mg will be equals to capital G small m, capital M small m by r square. So here I can cancel these two things, so g will be equals to gm by r square. So from this only we got the value as 9.8 meter per second square. Take down, this is the gravity. So 4 points completed no, this is the fourth point. So 4 points completed. Right on next point, fifth point. The value of g, small g, the value of small g, the value of g, the value of g is not exactly same, is not exactly same everywhere, not exactly same everywhere. Comma, it changes with the first point, depth, second point, height, and the third point is due to rotation of the earth, due to rotation of the earth. So depth in the sense as we go into the sea level, and height in the sense as we go into the mountain, like Mount Everest kind of things. Okay, and rotation in the sense like the longitudinal and the latitude, will say no, like in geography. Okay, so we'll talk about that. So first, under this first point, the first subheading, depth. In bracket the variation of g, in bracket you can write the variation of g. So write down the formula. Gravity due to depth will be equals to g into 1 minus d by r. So where this g is nothing but 9.8 meter per second square. This one we are going to find if they give the depth. So try to understand, like if this is the earth surface, no, if we go deep, okay, like deep inside in the sense like the core of the earth, we'll talk, no. So if we go deep into the earth, the gravity keep on decreases, okay. So here like the formula is, this is the g which we are going to find, and this is the g, that is formula is 9.8 meter per second square. D is the depth, r is the radius of the earth, which is nothing but 6400 kilometer, 6400 kilometer, 6400 km, the radius of the earth. Write on the first point under this. As we go below the earth's surface, as we go below the earth's surface, the value of gravity decreases. The value of gravity decreases. Similarly, like when we go to the top of the mountains also, the gravity decreases. Like due to this only the suffocation takes place. Okay. So write on the next subheading. Altitude or height. Altitude or height. So the formula is GH will be equals to G times of 1 minus 2H by R. Completed? Write on the first point. As we go upward from Earth's surface, the gravity decreases. Next subheading, Earth's rotation, due to Earth's rotation. Okay, write on the first point. Earth rotates about its axis Earth rotate about its axis. Because of this effective gravity becomes less in or decreases Write down the formula. G dash will be equals to G minus omega square r into cos square theta. G minus omega square r into cos square theta. Where first one under this omega is nothing but angular velocity. Omega is nothing but angular velocity. R is nothing but radius. Omega is angular velocity. R is radius. And theta is the latitude angle. Theta is the latitude angle. So don't worry about these three formulas, okay. They will provide the conditions and they will give the values of this, okay. The value of d they will give, the value of h they will give, the value of omega and theta also they will give. R value should remember, that is 6400. Sometimes they will give that also, okay. So only thing is calculation part. Only calculation part is the important thing in these three formulas, okay. Take 1 minute time and memorize this formula first. Write down next topic. Hurry, enough discussion over, no? Listen, I'll say one more 2 points under this. So first point is at poles, cos theta will be equals to 0, that is theta will be 90 degree, okay, theta will be equals to 90 degree, so cos 90 will be equals to 0. So if it is 0, no, what will happen? G dash will be equals to G. How 0? This value will become 0, this one will be there, no. If this becomes 0, multiply with this one, total becomes 0, so G dash will be equals to G. At poles I can say that the gravity is maximum. Write down next point. At equator theta is equals to 0 degree, theta is equals to 0 degree, which means cos 0 is 1, cos 0 is 1. So in bracket you can write G dash will be minimum, G dash will be minimum. Done. Now write the next topic. Gravitational field strength, gravitational field strength. Or gravitational field intensity, gravitational field strength or gravitational field intensity. First point, it is defined as gravitational force acting per unit mass. So the formula is E is equals to Fg by m. E is equals to Fg by m. So E is nothing but the field or intensity, will say. So the SI unit is Newton per kg, Newton per kg. Force is Newton, no? So Newton per kg is the SI unit. So what is the dimensional formula? ml t power minus 2 is the Newton, that is force, divide by again m. M inverse, m power 0 will come, or m power 0, no? For force it is m l t power minus 2, correct, na? Am I correct? For force, divide by again m. So if f mm cancel, so l t power minus 2. Next point, it's always directed towards, it's always directed towards the attracting mass, the attracting mass. under this the first subheading, one, field due to point mass, field due to point mass, field due to point mass. So if I talk about this, E is equals to G capital M small m by R square divided by M, no. If I expand this one, no, G mm by R square divided by M. So can I cancel this 2m? So it is G m by R square. This is the formula for the first one. Write on next subheading, gravitational field due to spherical shell, So what is the meaning of spherical shell? Shell, only shell. So if we talk about the egg is there, no, only egg shell. If I talk, inside nothing is there. So which means outside also nothing, inside also nothing, like only the shell I am talking. Okay, write on the point. Like can we say like a hollow sphere? The first point is similar to thin hollow sphere. First point is similar to thin hollow sphere, which is having a radius of capital R, Okay. So under this three subheadings, one is outside shell, one is on the shell, one is inside shell. Okay. So if I talk, this is my hollow sphere having the radius of R. So outside shell are having the radius R smaller. Okay. So first one, due to a point outside. So if I consider a point, any point outside, no, so can I say small r is greater than capital R? If I consider any point outside, can I say like small r is greater than the capital R? So the formula is, instead of capital R, I will write small r. That's it. Second one is on the shell. So on the shell, in the sense both capital R and small r will be equal. R will be equal to R. So E will be equals to Gm by R square. Completed first 2 points. Third one is inside the shell. So in this, what I should, R will be greater than small r, greater Here it will be total 0, that's it. Inside the shell nothing is there. E is equals to 0. Okay. Write on the point. Inside a spherical shell, inside a spherical shell, inside a spherical shell, gravity cancels from all direction. Gravity cancels from all direction. So which means the net field will be 0. The net field will be 0. Now you say small r is greater than capital R or capital R is greater than small r. Cancel each other. 2 we have talked, no, r is small r is greater than r, r is equals to r. What will be the third one? In terms of less than or greater than, I am asking. R less than r. Which r less than which r? Write down. Small r less than capital R. Okay. So one shape we have talked only, like that is hollow sphere. So second one is solid sphere. Solid sphere. So what about solid sphere? Inside nothing will be there or not? Like inside the particles will be there. So first one. So first condition, small r is greater than capital R. Small r is greater than the capital R. So if I consider a solid sphere, so the radius r and the point whichever I am considering, that is r outside, small r. So the formula will be similar. E is equals to gm by r square. Gm by r square. So on the surface or on the shell, so r will be equals to r. Same formula, E is equals to gm by capital R square. So next condition is r is less than r, E will be equals to gm by r cube. Right on next topic. Gravitational potential. Gravitational potential. First point, gravitational potential, gravitational potential gravitational potential at a point defined as work done per unit mass, work done per unit mass, work done per unit mass. In bringing a body from infinity second point, gravitational potential is usually negative because of attractive force, Right on next point. Because when a body comes from infinity towards a mass, gravity itself helps in pulling inward. So the external work is considered as negative. So work done per unit mass, no, so V will be equals to W by M. So one is like potential is different and potential energy is different. Okay, like potential is nothing but whether that person able to do or not, but the energy is different. Okay, right on next. Next topic, relation between gravitational field and potential. Relation between gravitational field and potential. And this like we'll do the problems based on this. Okay, E is equals to minus of dou V by dou X, that is I cap, dou okay, plus dou v by dou y j cap plus dou v by dou z k cap. This is the relation. So equation will be given, okay, it will be in terms of x, y, z. When we are differentiating, no, this is partial differentiation we will say. When we are differentiating with respect to x, like x, y, z is there. If I differentiate this one, no, keep this 2 as a constant thing. So only differentiate x. So I will get x as a y, z, na. This is constant. If I keep this as a constant, for example, y, z is there, I will take this as a 3. So 3x, no? Yes or no? If I differentiate this, what I will get? 3, which is nothing but y, z. Getting the point? This is partial differentiation, first thing, okay. They will give in terms of x, y, z, whatever terms. If I differentiate with respect to x, or if I differentiate with respect to y, or if I differentiate with respect to z, first I am taking the equation v is equals to x, y, z only, okay, x, y and z. So I am differentiating with respect to x here. So which means I need to differentiate only x. Only x I am differentiating. So which means these two are constant or not? Yes or no? These two are constant. When I am differentiating with respect to y, this 2 will be constant. I am differentiating with respect to y. So if I differentiate with respect to z, x and y. So what I can say? This is yz plus xz plus xy. Understood? Understood or not? Anyone? Still any doubts? Not getting? Till. ఇంకా ఎవరికైనా అర్థం అవ్వట్లేదా ఇంకా? Is there any question based on this? Good. Write down next subheading gravitational potential energy. Gravitational potential energy. Gravitational potential energy. Gravitational potential energy. So U is equals to minus G m1 m2 by R. Gravitational potential energy. Under this note point, the first note point, potential energy of many particles, potential energy of many particles. So the first example, so there is a triangle, so mass has been placed in each and every corner m1, m2, m3. So the distance between m1 and m2 is r12, and for this is r23, and this one is r31. Okay, they have not mentioned the distance, so we are considering the distance. Okay, the distance between mass 1 and 3 is 31, and 1 and 2 is 12, and 2 and 3 is 23, and they are asking what is the potential energy of this system. So each and every particle will act on each other, no, here, like if I keep 3 magnets, one magnet is acting on the other both magnet. So if I consider the other magnet also, similarly it will act on the other 2. Yes, no? So if I talk about potential energy, U will be equals to minus, I will take it commonly outside. What is the formula? G m1 m2 by r. So if I consider this m1 m2, m1 and m2, what is the distance? r12 plus, so one is acting on 2 also, one is acting on 3 also. If I consider 2 is acting on 1, 2 is acting on 3. If I consider 3 is acting on 1 and 3 is acting on 2. So G m2 m3 by r23 plus G m3 m1 by r31. Is there any other thing? 1 2 is there, 2 1 is there, 2 3 is there, 3 2 is there, 3 1 is there, 1 3 is there. Okay, is there any other thing? Similarly, can you do for this one, this square, m1 m2 m3 m4, do it until now first. How many will be there first? 4, only 4. One will be on 2, one will be on 3, one will be on 4. Then 6, 8, 12, 16, 20, 24, 4 tables, huh? Do it until work out. 6 is the answer, but do it until. What are the one, 2, 2, 3, 3, 4, 4, 1, and 1, 3, 2, 4 should be there, no? Correct, na? Completed. Tell. 1. Tell what are the masses? But you have written only 4. For example, the masses are given as m1 equals to m2 is equals to m3 is equals to m4 is equals to 1 kg. Okay, and the side of the square is 2 meter. Now get the value of this. Yes, yes, square, no, it is. The side of a square is 2 and each mass is 1 kg. Now what is the answer? Listen here. So 1 kg, 1 kg, 1 kg, and here 1 kg. So 2, 2, side of the square is 2 they have given. So u will be equals to minus of g m1 m2 by r12 plus g m2 m3 by r23 plus g m3 m4 by r34 plus g m4 m5 by m1 no by r41 plus g m1 m3 by plus g okay 2 4. So only for these two I need to take the hypotenuse, that is the diagonal of the thing. So remaining things can I find here? G I can take commonly outside. So one is 1 by 1 plus, so everything 1 plus 1 plus 1 plus 1, that is 4, correct no? Plus 1 by 2 root 2 plus 1 by 2 root 2. Which one? This one 4 by 2, okay. So here I can take 2 also commonly outside, minus g by 2 into 4 plus 2 by root 2. So I can rewrite this as minus g into, so g by 2 into 4 plus root 2 into root 2, if I do it, root 2. Okay. Either this one or this one, any one. This one I have done 2 by root 2 into root 2 by root 2. So root 2 and 2 will get cancelled, only root 2 will be there. Once you check it where you have made mistake. Up to this everyone got no? Up to this. So only you have made mistake here I guess, calculating the things. Root 5, root 2. Got the same answer? Same. You can copy down this one. Correct? Not getting. Which one? This step. So 2 divided by root 2, I can multiply root 2 and divide root 2. Right now? So root 2 into root 2, no? So it is root 4. Root A, root B can be written as root AB. So root 4 value is 2. Now these 2 and these 2, can I cancel it out? time.